Welcome. Today is part 12 of the chapter progression for preparation for joint entrance main advance and for different state level joint entrance examination. Our first problem today is problem number 55 of this chapter, and problem is find the minimum value of sum of the real numbers a to the power minus 5, a to the power minus 4, 3 a to the power minus 3, 1 a to the power 8, and a to the power 10, given a is positive. In this case, few numbers are there. These things, a is positive and real. This is given. So their minimum, sum of their minimum values we have to obtain. Sum of minimum value or product of maximum value, this type of problems can be solved simply by using arithmetic mean of few numbers is greater than or equal to their geometric means. The numbers are, you see, a to the power minus 5, a to the power minus 4, a to the power minus 3, a to the power minus 3, a to the power minus 3. They together is 3 a to the power minus 3. 1 a to the power 8 and a to the power 10. Altogether, there are 8 numbers 1, 2, 3, 4, 5, 6, 7, 8 numbers. So their arithmetic mean is a to the power, just 1 minute, a to the power minus 5 plus a to the power minus 4 plus 1 a to the power 10 by 8. Arithmetic mean of this number is this divided by 8, because there are 8 such numbers, and arithmetic mean is greater than or equal to their geometric mean. It means geometric means product a to the power minus 5, a to the power minus 4, a to the power minus 3 into 1 into a to the power 8 into a to the power 10 whole to the power 1 by 8. Now this is greater than or equal to, they together is 5, 9, 12, 15, 18 plus 18. So a to the power 0 whole to the power 1 by 8. So this is 1 to the power 1 by 8 is 1. So their sum is greater than or equal to 8 into 1. That is 8. So sum is greater than or equal to 8. So minimum sum is 8. Next. Next problem is problem number 56. And the problem is there are n cards having numbers from 1 to n. If two consecutive cards are removed, sum of the remaining cards is 1, 2, 4, 4. If smaller of the number removed is k, find least value of k minus 20. Achha, the problem is there are n cards, n number of cards, and having their numbers 1, 2, 3 up to n. So from them, two consecutive cards are removed. Of them, minimum number, two consecutive cards, of them, minimum number is k. So the number removed is k and k plus 1. And after that, after removing these two cards, sum of the remaining cards is that. Now, altogether, sum of the cards before removing is n into n plus 1 by 2, because it is 1 plus 2 plus 3 up to n plus 1 by 2, minus removed card is k plus 1, and they together is 1, 2, 4, 4. That is n into n plus 1 by 2 is equal to 1, 2, 4, 4 plus 2k plus 1 is equal to 1, 2, 4, 5 plus 2k. Therefore, n into n plus 1 is equal to twice of that, plus 4k. Now, we have to find the minimum value of that. So k depends on this. So k will be minimum when n will be minimum. Now on trial, we have to find the value of n. If we take n is equal to, on trial, n is equal to 49, this is equal to 49 into 50, that is 0, 2450. If we take n is equal to 49, n into n plus 1 is 2450, but it is 2490 plus something. So this must be greater than 2490, but this is less than 0. So n is equal to 49 is not at all possible. Next, take n is equal to 50. So n into n plus 1 is 50 into 51 is equal to 0. So that n is equal to 2550. So it is actually this plus that. So this one is greater than that. So least n is surely 50. In that case, 4k will be equal to n means 50 into 51 minus 2490. It is equal to 0 minus, therefore and it is equal to 60, so that k is equal to 15. So least value of that is 15 minus 20, that is minus, oh sorry, actually the problem is find the least value of k minus 10. I'm very sorry. To find the least value of k minus 10, the least value of k is 15. Therefore, least value of k minus 15 is 5. So 5 is our answer. Next, now next problem is problem number 57, and the problem is, let the harmonic mean of two positive numbers a and b is 4. Harmonic mean between two positive numbers is 4. Let q is another positive number such that a, 5, q and b are in AP. Then find the possible values of modulus of q minus a. Possible values of q minus a. Between a and b, 4 is a harmonic mean, so we must have 4 is equal to 2ab by a plus b. This is harmonic mean is equal to 2ab by a plus b. From there we get ab is equal to 4 into ab is equal to 2 into 2 cancels 2 into a plus b. Suppose this is 1. So next case, they form an AP. Therefore, their common difference is D is equal to 5 minus A, common difference of the AP. And as because B is the fourth term, B is equal to A plus 3D is equal to A plus 3 into D means 5 minus A is equal to 15 minus 2A. So B is equal to 15 minus 2A. And Q actually equal to, Q is the third term of the AP. So A plus 2D is equal to A plus, D means 5 minus A, 2 into 5 minus A. So that it is equal to 10 minus A. Q is equal to that. Okay, next, to find the possible value of that, we have to find a value of A, and that is possible from eliminating B from this and that. This is a relation between A and B. This is a relation between A and B. So AB, we eliminate B so that we get a relation of A only. So this is equal to A into B. B means 15 minus 2A is equal to 2 into A plus B. B means 15 minus 2a. 15 minus AB, 2 into a plus b. A and b is 15 minus 2a. So that we get this is equal to 2 into 15 minus a. So we have 15a minus 2a square is equal to 30 minus 2a. That is 2a square, taking into that side 2a square minus 17a minus 2a minus plus 30 is equal to 0. So it is a quadratic in A. Now we can solve it. By factorizing, it is 60, 15 and 2. Achha. So it is actually equal to 2a minus 5. How to factorize a minus 6? So that it is equal to 2a square minus 5a minus 12a plus 30 is equal to 0. That is, taking 2a common, a minus 5, sorry, a common. So between these two, taking a common, 2a minus 5 minus 6, 2a minus 5 is equal to 0. That is, we have either a minus 6 or 2a minus 5 is equal to 0. So a is either 5 by 2 or it is 6, this and that. So we get two values of a. So now to find when uh, q minus a, the difference, magnitude of the difference q minus a we have to obtain. Achha, a is clearly known in terms of known terms, and q minus a, q and between relation between q minus a is this. This is equal to that. So now for two values of a, we find values of d. D is when a is equal to 5 by 2, d is equal to 5 minus 5 by 2, that is 5 by 2. So q minus a, q is your 10 minus a minus a. So that 10 minus 5 by 2, 10 minus a. This is your q minus 10 minus a minus a. 10 minus a. That is, it is equal to 10 minus 2a. No, no, no. D is equal to 5 by. When a is equal to 5 by 2, in that case, d is equal to also 5 by 2. So that it is equal to 10 minus 2a means 5. So one possible value of this is that when a is equal to 6, q is equal to 10 minus a is equal to 10 minus a. So magnitude of q minus a is equal to magnitude of 10 minus 2a, q minus a minus a. So that 10 minus 12, 2. So another possible value is 2. So either it is 5 or it is 2. Base. Next problem. Next problem is if problem number 58. If 10 to the power 9 plus 2 into 11 to the power 1, 10 to the power 8 plus 3, 11 to the power 2 into 10 to the power 7 plus 4, 11 to the power 3, 10 to the power 6 up to 10 into 11 to the power 9 is equal to k into 10 to the power 9. This relation is given. Then find the value of k. Now dividing throughout by 10 to the power 9, we must have k is equal to, this is 1 plus 2 into, dividing by 10 to the power 9, this become 10 to the power 9. So 110 will be there. So it is 11 by 10 plus 3 into, dividing by 10 to the power 9, in denominator it would be 10 to the power 2. So it is 11 by 2 whole square. Next term is 4 into 11 by 10 whole cube and up to 10 into 11 by 10 to the power 9. Now clearly k, this is a series containing these terms. You see, one is increasing with AP because it is 1, second term, first factor is 2, 3, 4, 5 up to 10. So they are increasing in AP with common difference 1. And other factor, it is 10 by 11 to the power 0, 1. 11 by 10 to the power 0. It is 11 by 10 to the power 1. This is 11 by 10 to the power 2. So, second term is increasing with GP, whose common ratio is 11 by 10. So, it is called AP-GP series. And the method to calculate for AP sum of AP-GP series, we have to multiply throughout by common ratio of the GP series, that is 11 by 10. So 11 by 10 into k is equal to 1 into 11 by 10, and I write it by shifting one step. So it is equal to 1 into 11 by 10 plus, this is, multiply this by 11 by 2 and write it there, 2 into 11 by 10 whole square plus. Now multiply this with 11 by 10 and write it there. So 3 into 11 by 10 whole cube. This way, this term was 9 into 11 by 10 to the power 8. So it is 9 into 11 by 10 to the power 9 plus 10 into 11 by 10 to the power 10. Now subtract. This is equal to this minus that, but this minus that. So 1 minus 11 by 10. 1 minus 11 by 10 means minus 1 by 10k. This minus that is equal to this 1 plus this minus that is 11 by 10 plus this minus that, it is 11 by 10 whole square, then also 11 by 10 whole cube. Up this way, this is also 11 by 10 to the power 9, and this become minus 10 into 11 by 10 to the power 10. Yes. So from this up to that, this become a simple GP series, and very easily we can add them. 1 minus 11 by 10 to the power next higher term by 1 minus common ratio. This is up to that minus 10 into 11 by 10 to the power 10, and left side is minus 1 upon 10 k. So they together is minus 1 by 10. So that this is equal to minus 10. 1 minus 11 by 10 means minus 1 upon 10. So that 10 is there and with a negative sign, into 1 minus 11 by 10 to the power 10. Minus 10 into 11 by 10 to the power 10. Now you see, this is plus 10 into 11 by 10 to the power 10, exactly that term with negative sign. So this cancels with that. So it is equal to minus 10. So minus 1 upon 10k is equal to minus 10. So k is equal to negative cancels 100. So sum of this series, APGP series, this series is k. I mean k is equal to that. I mean if k is equal to 100, then k is equal to 100, then this series is equal to that series. So answer is k is equal to 100. Okay, let us stop today, and I request you to like, share and subscribe my video. Once again, thank you.